Hey, how about I turn this thing on? Greetings and salutations. Well, let's see what happens here. It is now 9:30. Let me go see if I have any messages from young Mr. Riley. And hold on a second. Dum, 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 dum. It's going to be very interesting whatever this decides it's going to produce because well, Riley says, no, I don't want to talk about Bride. No, I don't want to talk about Ramsey and all this. So we'll see what's up. Alicia, what's up, Blue? What's up, everybody? All right, let me go see if I got any messages. Let's see, messages. Uh, I don't see an what? This is funny. He wrote me a message 2 hours ago. I don't see an advert scheduled event for 3 hours before Sly. Is this not happening? Dude, we even agreed yesterday that it was going to be same bat time, same bat channel. Hold on a second here. Let me put this back up. But I'll go ahead and write him back and send him the link. Here, hold on a second here. Ba, 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 ba. Let's see, there's that. And I am inviting nobody else. I am only sending a message now to reply to Riley. See, Riley, I'm actually, you wanted it to be greater than 3 hours out. This is 24 hours plus 2.5 hours. So, you know, let's see if he comes in. And I can't wait to see what gets discussed here. Maybe I should break out into song. What do you think? Bum, 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 bum. See this? These are tears of flat earthers falling down. So let's see if he's gotten my message yet. Oh, I actually have a very good singing voice. Let's see. Okay, I'll reply to some comments while we're waiting here. Let's talk about the perspective omitting proof of nothing, begging the question or assuming metabunk. Yeah, okay. Whatever that meant. Yes, I did. IFTH. I got that, but unfortunately, I had already had it before then. But I did get it, and I thank you very much. I really do. Well, paper explanator. Um, there we go. Sly, don't you do messages in YouTube? Yes, I did. I sent you a message in YouTube, buddy. As a matter of fact, if I trim it back a little bit here, I'll even show you. See? I sent it to you. Here it is right here. Might want to check in your spam folder. Viva tutti le vezzose, donne amabili amorose. Come on, I'm going to torture people with my singing voice. Well, there he is.
Oh,
Riley?
hang on.
Okay.
I hear you. Hang on, what's going on here?
I
Okay,
can
I
hear
got
you
it.
too.
It's because I've not got you on the speakers. Just give me a sec while I set some things up.
Sure, no problem. Blue, no. Nobody's going to be invited in during this particular discussion. It's just I
So what happened to the
not something I
what happened to the advert? I thought we were going to get like a nice juicy hangout advert, so we knew that it was definitely happening.
did. You saw it yesterday.
3 hours before, man. So I knew you were definitely going to be doing it. Did you not get that bit of the message?
Yeah, and that was actually 2 3/4 hours before that. But we're not going to go into that, are we?
Well, that's I'm gonna have to set a couple of things up here because I didn't get. I sent you a message an hour ago and I didn't get a response, and I thought, not like Sly, what's going on? And then when
Oh
I looked,
no, I was eating dinner.
yeah, I've not had mine yet.
Hmm.
Right, let me work out what's going on here. I need to do a little bit of housekeeping here because I'm not quite ready for you. You'll have to bear with me a sec.
You are aware that we actually decided to postpone this 24 hours, so it's not like this was a surprise.
No, but it was just I didn't get any contact from you or a link from you until 2 minutes ago, so I didn't know that it was on.
Well, I can't give you a link until I don't have a link, man.
True, but an acknowledgement would have been good.
I gave you acknowledgement yesterday.
Okay. Right, so display capture. New. What? What is going on here? I'm going to have to do this on this, aren't I? Oh, God damn it.
Viva sempre delle donne sulle riva. La pramata se lealtà, le vezzose, viva, viva. Gli amorose, viva, viva.
Okay, I'll have to swap things. For some reason, my OBS is not picking up my other screen that I wanted to share the Hangout on. So I'm going to have to move things around so that I don't accidentally share your link. Because I remember I did that accidentally last time, and I don't want to do that again.
I don't know if you did that with me, but if you did, nothing came of it.
No, I did. I did it accidentally, and I said, "I'm sorry. I'm so used to sharing on Nathan's screen where it doesn't matter. I did it accidentally, and I didn't." So what I'll have to do, maybe that one, that one.
For all the comments in chat, Riley was not yet prepared to go onto the Hangout.
No, I am prepared for the Hangout. I just didn't know that it was happening because I didn't get an acknowledgement back from you an hour ago. That's okay.
How many acknowledgements do you need, man?
Well, one that was 2 minutes ago was not kind of, telling me that we're on.
So the one that was yesterday wasn't enough for you?
I didn't know that you hadn't been run over by a bus. You know what I mean? Stuck in work, the usual kind of stuff.
So you weren't actually like prepared to set up a hangout of your own, just to say that I didn't show?
Oh no, I'm ready. I've got the Hangout ready to go. I'm just going to set my OBS thing up. So just give me a minute while I remember what I'm supposed to be doing. You distracted me a little bit. So I need your Hangout thing there. As long as I can put this one over the way, I'm not inadvertently going to share your link.
Oh, by the way, who was the while you're setting all that up, who was the Chris that you mentioned that made that turbine graphic?
Chris from FE Core.
Chris who from FE Core?
Chris Sally.
Selly? Is that his YouTube name?
I think it might be Chris Sally. I know it was Chris Monk or Chris Sally.
Okay.
Why you got? I know you got a problem with it, right?
Oh, I debunked it yesterday, but don't worry about that.
No, I don't think you could. It was dealt with this morning.
Dude, that graphic is such a fraud. That graphic is such a fraud. Yes, it is. I even have the. I'll pull up the model later if we have time.
Sure.
And is that the same guy who made your Isle of Man thing?
Yeah, but I'm pretty certain he's got it right.
Pretty certain. Yeah. Now
Yeah.
you're getting a little weak in the knees there, Riley.
No, but I'm pretty certain. If I had to flick a coin between which one would I go with, yours or his, I'd go with his.
Well, I'm sure you would because he's from FE Core. You know, I mean, he can always give you a PDF. But oh, Chris Mong, Mong. See, I looked up Monk today.
Monk, Chris Monk, that's his name.
Oh.
Ah, there we go, got it. Now I can go back to the way I was going to do it. Right, so I'm nearly there.
Take your time, Riley.
I'm on it. Right, so I need to trim off the top of it so that I don't accidentally share you, because that would be bad. Right, so properties, filters, and trim that off.
Well, I only found two Chris Mongs on.
No, MONK.
Yeah, I saw that one, but he ain't got that either. I got Chris Monk Selly, but he didn't. I looked at that one today, and he didn't have that graphic either.
Well, that is the guy, Chris Monk Sally.
Oh, okay.
Right, so that should be that sorted.
I thought it was oddly ironic that he made a demo FE Core ad where he put FE on or FE Core on a sphere. I thought that was humorous.
On a smear? What do you mean?
Sphere.
Oh, sphere. Well, yeah, that's the field engineers, right? They're not flat earthers.
What?
Field Engineer Corps it stands for.
It's Flat Earth Core, isn't it?
No, Field Engineer it stands for.
Oh, okay. Well, Flat Earth, Field Engineer, Tomato, Tomato. Who cares?
Curve, flat, yeah, you know. I'm getting there.
But I'll tell you this: I would dare not call them engineers.
Well, they are subject experts in their own relevant field, right? You'll have an accountant, a lawyer.
Are any of them having to do with the shape of the Earth?
Technically, no, but unofficially, yeah. They're testing things with lasers over vast expanses of flat water, right? So by definition,
fail it every time, so that's not really good.
What are you talking about, man? Come on. Right. Anyway, so
page 13 of the PDF. Read it. But anyway, so what did you not want? What did you actually want to discuss? You said this isn't about Ramsey. You said this isn't about Bride. For some reason, it's probably not about perspective. So what did you want to discuss on this?
Creative. I'm just putting me titles in. I'm nearly done. There we go.
Titles in?
Yes. Give me a minute.
Yeah, that's a good point there, Dedalore. Field engineers that can't do proper 3D graphics. And the fact that you even brought it up, I'm sorry, it doesn't look good for you when you do that, man. Here, while you're setting up, I'll go ahead and bring that up here. Let's see here. First thing that was wrong with it, and the most obvious thing that was wrong with it, this is the PDF or the PowerPoint that I was working on last night. Yeah, it's displaying the apparent curvature in the model before the horizon. As in, it's curving down into the water before the horizon. Go figure on that. But I mean, that's highly accurate modeling, of course. And so because it's all going down. See how it goes down here? Are you looking at my screen? Probably not. It's going down. It's going down into the water before it even gets to the horizon. Whereas any person you discuss this with, that wouldn't happen until after the horizon. That's when it starts going down again. But and not to mention the parallax that was on here. I think I determined it last night to be. You said that this was a model of something between 11 and 13 miles. Unfortunately, that's not how it worked out in the model. And when I modeled it last night, this was shot from about 5 kilometers away. So
Oh,
the so I mean, just little details like that, and
well, do you want to bring up the curve calculator and we'll just run the basic figures through it and then see what
is the curve calculator going to have anything to do with this image?
Yeah, directly.
How?
Well, if you put in a curve, if you put in your observer height at say 2 feet,
Mm-hmm.
and then you put in 11 miles for the observation for the first turbine, and then you see what it says for the refracted hidden, and then you put in 13 miles to see what it says for the last turbine, and then you aggregate the two sums, you don't get 12 inches.
I don't know what the 12 inches is, but hold on a second here. See, now you act like I don't check these things.
Well, I'm not sure what you know and what you don't know, so I'm just starting with things that we agree on.
Do you think I would have brought it up if I didn't test it?
Sure.
Aside from the obvious error here.
You're a disingenuous piece of curvature. Of course, you'd bring it up.
So you think that this is a genuine drawing here? This thing here is genuine. This is an honest representation in 3D of what this would be.
Well, I don't know what he's done or what he's not done. I don't know whether
no. You brought it into Nathan's Hangout saying this is exactly what it is.
Yeah, my understanding is that this is a replication of turbines from 11 to 13 miles.
Okay, well then your understanding is completely destroyed. Because look, I did this last night, and I could do it again for you if you want to, but I really don't want to waste my time too much on it. But the what do you call it? The towers actually sink into the water before it even gets to the horizon, displaying X curvature. Okay, that doesn't happen in reality. Doesn't happen in perspective. Doesn't happen in anything. It only happens when people deliberately modify or deliberately screw up a graphic representation.
Okay.
Deliberately.
Well, this is the way I understand it.
Understand my word deliberately first.
Yeah, I understand deliberately, but let me show you why deliberately isn't the right word. Pull up the curve calcs.
Why am I going to pull up the curve calcs? I'll pull them up, but I mean, tell me why I'm doing it.
Because that gives you the accumulated drop that you deny is there.
Really?
Yeah. So go to Metabunk.
Okay, Metabunk.
Or a curve calculator of your chosen.
No, since you're a favorite of Metabunk. Let's see here. So Metabunk calculator, go for it.
My mouse appears to have died. So your first turbine is at 11 miles, I believe. Is that right?
Okay. Distance 11 miles.
Sure, and then put your 3 feet, 2 feet, 4 feet, whatever you want.
Sure, no problem.
So the refracted hidden there is 43.35 feet, correct?
That's what it says, yeah.
Now remember 43. So change your distance in miles to 13 to represent the last turbine.
Right.
So 43 becomes 65. So you've got 22 feet of accumulated drop, correct?
Right.
So your position is that
show me how many feet is how many feet on this.
Well, look at the straight line on the picture on the right. There's not 22 feet of accumulated drop in that picture.
That's not what I asked you. I'm talking about the graphic first.
Well, I don't know what the scale is, but I could easily argue that there's the.
But you're arguing that the scale is correct.
But I don't know what the numbers are. I know what the numbers are.
You just read me off the numbers, and you even said in the Hangout the first one was at 11 miles, the last one was at 13 miles.
Do you see a ruler on screen?
Then why did you bring it up?
Because my understanding, this is based on turbines of 11 and 13 miles.
Okay, so what you're saying is that you just brought it up just so you could bring it up then.
I'm saying that this is representing the curve that you would expect to see at 11 being the first turbine and 13 being the last turbine miles.
Now, here's the funny part. Now, according to this, according to what you just had me look up, which was the Metabunk calculator, right? Now, according to this, going back to 11 miles, okay, already beyond the horizon, already starting to go below the horizon, right? As in, there's already stuff that's already hidden.
No, but we're testing for the accumulated drop.
No. Listen to me, man. Listen to me.
Go on.
Okay. At 11 miles, at 3 feet above the water,
yeah,
there's already stuff missing. Right?
Sure.
Bottom up missing, according to the curve calculator, correct?
Sure.
So if you were to model out a proper curve, then none of this would be in front of the horizon, right?
Fair enough.
Do you understand my point now?
Sure.
Okay.
Well,
now,
I'm not.
let's go over to your image here that you got here on the other side. The turbines that you and Nathan love to harp on. Hold on a second. First of all, there's only about 2 miles. This is about a 2-mile stretch, you said, right? 11 to 13 miles, roughly 2 miles.
I believe so. Yes.
Okay, roughly 2 miles. Now, now what I did, and I even modeled this out live last night, just because sometimes I get bored. Now let's see on the curvature cam. Oh shit! I got to put the camera back to where it was. Okay, what I have here is I have 2 runs. Okay, one is over a flat plane, and one is over the over a half-degree curve. This right here represents half of 1 degree of curvature. Okay, and let's see here. I think it was like 55.66 kilometers or something like that. And now I'll go ahead and put these down here. I think that's just, I think I just got it at 10 meters right there. There was no particular reason for that other than just to have it there. Now, now you can see here, oh, shit, I got this thing in the middle still. Unfreeze all. Get this thing out of the way because it's just a graphical nonsense. Okay, so this the units here are in kilometers, as in each one of these is 10 kilometers, and I think the first one starts out at 17 kilometers. The last one was I don't remember anymore. Just don't have it off the top of my head. But you know, you can screen cap this and look at it all you want to your heart's content later. But as you can see, one is a curved one and one is not a curved one. You agree with that?
Yes.
Okay. Now, if I look at, oh wait, I got these things pointed in 2 different spots because I was asked last night to show the side view of that as well, and that's why that was offset there. So, from the curve cam, okay. Now curve cam, I got to zoom back in. Damn it. Curve cam, okay. So down to the extent of 1 degree, which is on or about the same as a P900, I think. But I think P900 can actually go lower. I think you guys actually know that better than I do. Let's see here. Now, top. I got my offsets a little bit wrong there.
You're not going to actually credit us for doing our own research, are you?
What's that?
You're not actually going to credit us with doing our own research?
No, but you guys are real good at quoting shit, so. So, these are offset on each other, okay? Now, this right here is what you would see from those turbines to scale with perspective.
How far away are we on the curve there, though? Because you look quite close.
Well, I'm zoomed in. I can zoom back out if you'd like to see that.
Zoom back out from the 11 miles away, and then let's see the accumulated curve.
Okay, so there's zoomed out to a 45-degree field of view. Okay, you can barely even see the damn things.
Yeah, that's half the problem. But how do you show it with the computer-generated design, showing the distance and the effect of the curve without zooming into it?
The distance. Okay, let me break you down on this here real quick. What I did here is first, you know what? I'm gonna let's see front. Let me go over to the left here just so it's not a confusing view. I'm gonna grab all of the curved one and move it down real quick. So what I did was I created a long block. Okay, do you see this long block?
Yes.
That long block is 55.66 units. Okay, or yeah, I can actually, well, no, it's in a group now, but 55.66 units means 55.66 kilometers long to scale. Okay, it's just a stretch of land, which is half of the 111 point whatever kilometers that would be needed for 1 degree of curvature per the stated circumference of the Earth. Okay?
Yeah.
Do you agree with that?
Sure.
Okay. So what I did, and then when I went into here and I built just these silly looking towers. Okay. Each one of these towers, the base is 100 meters above the surface. Okay, it's scaled to 100 meters, and then I just put this kind of football looking thing at the top to represent the turbine. I did not model blades because blades just obscure the view. Do you agree?
Fair enough.
Okay, so, and then I made, per this diagram, I made 9 of them. Okay, this one's got 9, this one's got 7, but you'll see in a second here. Okay, so I made 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, I put all those on there. They are all identical height. They are all just basically, it's just a copy and slide, copy and slide, copy and slide. That's all it is. Okay. Now, for the flat, or then what I do is I put a camera all the way down here, and then I gave it a target so I can actually move it a little better. Anybody who's ever done 3D knows how hard it can be to move things when you're zooming in. Okay, this is the target of that camera.
Sure.
Currently, right now, it is zoomed into 1 degree. Okay, and what do you call it? So this right here, being the flat cam, is what I called it. Now I'm going to go over here and take the view of the flat cam. I moved that damn target up again. Hold on a second. Okay, so this is what you get. Well, if it doesn't crap out on me. Oh, it's got to wait for the hard drive to spin up. Interesting.
You're still on HDD drives. Now,
Well,
see,
one of my storage drive I have.
I have an issue here, though, Sly.
Okay, no, hold on. Okay, now this is what that would look like across a plane.
No, that's not what it looked like across a plane.
Yes, it would.
No, it wouldn't.
All of the bases of these posts would be lower than the horizon.
How high is the camera height?
Camera height, I think right now is at 10 meters.
10 meters? Right, drop the camera height down to like 3 feet.
Sure, no problem. So let's see, 3 feet, and that should be about 1 meter then, right?
Sure.
So I put this at about a fair 1 meter, right?
Okay.
Actually, you know what? Let's be precise.
3.3.
Hold on. All right. So what is it? 3.3?
Sure.
3.3 meters. Okay, let's make sure we're. Oops. No, I got that in meters. Well, I gotta. Oh wait, I know how to do this. You said about 3 feet, right?
Sure, 3.3 if you want to be.
Okay, so all we do is we'll just move this down to 1 meter. Cool. So let me move my camera down. Oops. Selected on the wrong bit. Okay, right down there at 3.3. Fair?
Sure.
Put it right there as exact as we can get. So, front, camera. Flat cam. All right.
No, and that's still not how we'd see it on a flat plane.
That is what we would see on a flat plane, Riley.
Are you in perspective view or orthographic?
I am in camera view.
Camera view. So why is it that the bases are not rising up to a horizon the way that I see it through a lens?
Because they're not rising up to the horizon. They're beyond it.
Oh, these are all beyond the curve?
No. This is all across a plane, what you're looking at right now.
No.
This is across a plane.
The bases all go up to the horizon. So these must be beyond the curve because they're above the horizon, right?
No. These are at the horizon. Here, I'll even put in a nice high definition for you. Oops.
Well,
Doop. No, hold on. Oh, that wasn't high. Okay, hold on a second. Let me go ahead and like this. See this? About a good 2-3 pixels below the horizon and gaining as they get closer. Okay?
All right, I'll give you that. Go on then.
All right. So that's what you would expect to see across a plane. Period. Now, what I did, let's see, showing from the right. Oops. Nope, that's right, from the front. Because I did it sideways. Okay, now what I did was I attached all of these towers to this block of land. Okay, this 55.66 kilometer long block of land. Okay, and then I bent it by half a degree. You can even see it's still here, bent by half a degree.
Sure.
Okay, which bends these things along that surface. Okay, that's all it does. Now, if I go to the curve cam, this is the. Oh wait, let's bring us down to 3 feet. If I bring us down to 3 feet, there's not going to be much left there. I think that was probably. Well, let's be precise here. Now I'll just zoom back in and do a new one. Tape. Oh, it's already set. Okay, so I was actually a little too low. So we are now at 3.3. Do you agree?
I do.
See the edge of the line there?
I do.
Okay. So, and now I'm zoomed all the way out now. So let's see here. So front, go over to curve cam. Now I'm zoomed all the way out. Okay, I think I'm zoomed out. I think I just put it at 45. Yeah, 45 degrees. Okay. So let me go ahead and zoom back in, back down to 1 degree. Oops, too far. And then let me grab that target. Oops, curve cam target. Lower it down a little bit just so you can see the stuff a little bit better, that's all. And this is what would be going on the curvature. Okay, they are all, now you wouldn't see obviously this, but as you just pointed out, and I appreciate you pointing that out, what we see in reality is all of these towers at the horizon. That's because all of these towers at the horizon means that their bases are beyond the horizon.
Sure.
That is how perspective, that's perspective over a curve right there. And the reason why I made a video about this the other day, I did a whole nother video on it, was because of the fact that if I put this back into split view here, now let me solidify the ground real quick. Oops. As in make it so it's not transparent. That's all I'm going to do. So opacity 100%. Now, if I look at this one, then I look at this one, with the exception of the heights, you tell me what is it that looks tremendously different about these two.
I want to know what mode you're in here. What's your viewing mode? Can you show me?
I'm using a camera on each one. I'm in a camera. Right.
Can you show me what mode the viewing mode of that camera is? Because normally you've got an option that says perspective, orthographic. Can you show me? Can you confirm?
Well, actually, you only have two. You can put in orthographic, but I'll gladly put in orthographic for you.
Yeah, because I want to see you flick between the two so that I know that you are on perspective.
Oh, there is a wild difference between the two. These would all be the same height. Let's see here. Orthographic. So there's orthographic view on the flat cam. And then let's go over to the curve cam. Go to orthographic view on the curve cam. Satisfied?
So then take the tick out of both of them. So let me see it with the tick out.
What do you mean the tick?
You had orthographic selected, didn't you? I want you to deselect orthographic now so I can see the difference.
Oh, sure, no problem. We'll go back to curve cam. That's going to be this one first.
Okay.
Take that back out. And then go over here. And then I got to get flat cam. Flat cam, take that one out.
So why, when you flipped it into orthographic, have they not gone into the same height? Because isn't the whole point of orthographic that they maintain the heights on the flat one? Shouldn't they be all the same height?
No, because orthographic takes any and all depth perception out of it, and this has to do with the with the depth perception as well.
Okay. Listen, to be honest, like at this point, I'm not the modeling guy here. To be honest, and this isn't passing the book, but I'm not skilled enough in the modeling thing to be able to argue this either way. So I
Okay,
don't know
well,
whether you're going to be able to use a sleight of hand here and catch me out.
oh,
It might be,
that's why I gladly I modeled it last night. But now this picture that you have here, what do you call it? This one right here. Now there seems to be some kind of basage on here, but there's nothing that you can look at that is in any way consistent, right? I mean, there's just a dark spot there and all this. I mean, I don't see any like designated, base like this stuff, right?
sure.
And so the reason why I pointed this out the other day, as I called it, quite honestly, the most worthless picture in globe or flat claims, is because of the fact that with at the correct angle, as in left to right angle, not high and low angle, but at the correct angle, can you really see much of a difference between these two images?
No, not really. But when you run the maths on the first turbine at 11 and compare the maths to the 13th mile turbine, then you have a difference of 35 feet. And
Yep.
I'm wondering why you're not demonstrating the 35 feet on the curved one.
I'm not demonstrating it. What do you mean by I'm not demonstrating it?
Well, do we agree that the refracted hidden on the 11th turbine is
There's
one?
no refraction in 3D modeling.
Yeah, I understand that. All right, so without the refraction, and let me do it without the refraction.
Mm-hmm.
Wait 30 seconds. Distance in miles was 11, and we did it at 3.3. So without refraction, the hidden value should be 51 feet for the first turbine,
Okay.
and for the last one, it should be 51 to 77. So 61, 71, 3, 4, 5, 6, 7, 6. So 26 feet. There should be 26 feet difference between the first one and the last one on the curved model. And yes, we should see that compared to the flat.
Oh, okay. Hold on one second here. Doop, 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 da-doo.
I'll just show them.
Okay, so these are the two models. Okay. Now, I got to put the microphone down here real quick. I hope you can still hear me.
Yeah.
All right, so here's what I'm going to do for you. Now, these are all on both of them, on both models. Obviously, it's the same ones. I have them slated as 100 meters tall. Okay. Now, go ahead and give me the meter drop on each one
For
at 1 meter viewer height.
for the first one at 11 miles.
Right. Give me, or excuse me, not the meter drop. We can do drop, but give me the meters obstructed.
Hidden.
Hidden, right? From the first one and to the and the last one.
So the first one, the hidden is 51 feet.
Give me. I need it in meters, man.
Oh, hang on, metric. 15 meters, 15.65.
15.65. Okay, so hold on a second. We'll put this in as length as 15.65. Okay. And then what is the last one?
I'll have to flick it back to Imperial, flick that to 13 miles, and then do it back. The 13 miles back to metric is 23.6 meters.
Okay, 23.6 meters. 23.6 meters. And then put that up to the surface. Now, you agree that those are the heights that are supposed to be blocked, right? The two that I just gave. Okay, now first I just modeled that on the flat one because the flat one is easiest to view. Okay, so we'll go to the flat cam first.
So this is a forced failure, right?
I don't know if you would. I don't know what that would mean.
It means that this is not supposed to work. This is supposed to fail.
Well, the first one here is just to show an example here. I just realized that it was turned. So let me go ahead and turn it halfway on each of them. The like that. Okay, so okay. Oh, I know why I didn't see it. Because they're not on the towers. They're way out in the middle of the viewport. Hold on. Top. Yeah, see they're not even where they're supposed to be. Okay, so this is the flat one. I'll put them over here. Now what all I'm doing is this is the last one right here. This is from the top view right now,
Sure.
and here's the first one.
Okay.
It's just when I drew it, it actually drew it way over here. That's the problem with orthographic view. Okay, so camera, flat cam. Now these are things that we would expect to see covered if this was on a curved surface, but right now we're looking at it on the flat surface.
Yeah.
Okay.
And we can see that there's a discrepancy, right?
Yeah, you can see the discrepancy, of course.
So we would expect to see a discrepancy on the curve as well, wouldn't we?
Nope.
Because
Watch.
it would be,
No.
wouldn't it be what you're demonstrating there is that we should see a curve, right?
No. Slow down, man. This is right now. This is just across the flat plane.
Yeah, and we can see the difference between the two drop values, correct?
We can see the difference between the two. Yes.
Right.
You
So
should be able to see the difference between the two.
Yeah. So flipping that the other way, if it were a curve and there was that discrepancy between the two values, then we should see a curve, right? It would be flat. What I'm saying, because you're flipping it.
Right. The tops should meet is what I think you're looking to say, right?
Yeah.
Right. Okay. So now I'm going to do is I'm just going to take those two items here. Okay. Here they are. These two little dots right here. Sorry, it's just kind of small scale. Okay, so I got these on. Oh, now I got to go to the top view. Sorry, so I can move them onto the right surface. Okay, so like this. Okay, you see those two dots moving up and down?
Yeah.
Okay. Silly me, I was pointing at it with my finger on the screen. Let's see here. So now let's go down here to them. Okay, so now what I'm going to do is I'm going to take each individual one and I'm going to put it at the surface of each location. Just like on the other one, it's just on the curved surface now. Okay?
So these should flatten out, right?
Should. Plus or minus a centimeter. I don't know how accurate or how precise of a number you gave me, but you know, I worked with it. Yeah, it's fine. Let's see, curve cam. Well, look at that. And as a matter of fact, let me go ahead and I'm going to. Oh shit, that's all a group. Damn. Okay, now do you see a little bit of pink back here?
Yeah, but what that tells me is that you've got something's wrong with your model, because it should be the case that when you flip them the other way, they should be flat.
Yeah, that's what I'm saying. Hold on a second here. Let me go ahead and let me ungroup everything here, because right now it's still grouped from when I bent it. Let's see, ungroup. Okay, so let me go ahead and let's see. Well, I'll just move the damn thing.
I'm just wondering how good this is, like, in terms of my prowess on this stuff.
Okay, now what I did was I just moved the horizon out of the way. I didn't move the camera or anything. I just moved the horizon out of the way. Okay, did you see me do that? You want me to do it again? Okay.
Yeah, no, I'm all right with the horizon being moved.
All right. What do we see here?
Pretty flat.
No. What do you see with the tops of these two things here?
They look like they're lined up.
Lined up perfectly, and they are each individually. The bottoms are the same height as their towers that they're next to.
Move down out of the way so I can see.
Oh, sure.
Well, no, the bottoms don't line up, do they? Because wouldn't that be the curve?
What?
I don't see.
Let me tell you. See, I listened to you enough times about how you got the drop and obstruction mixed up. Okay, so hold on a second here. Now let's see, 11 miles, 3 feet. What'd you say it was? Oh wait, we got to go back over to metric.
One of them. So one of the 23.6 was for the one that's furthest away.
23.6. What are you talking about? Oh, for the furthest one?
Yeah, 23.6 meters.
Okay, I think I'm just a little bit too high on there because of the fact that it was actually I actually had this at 1 complete meter. Yeah, there it is. Okay, now you saw me model those out, right? Those two little height things that I just did, right?
And I saw that when you put it on a flat plane, we were able to distinguish between the two drop values. The difference.
Correct. Correct. You can see that one was actually taller than the other.
Sure.
And as a matter of fact, the more distant one was actually a bit taller than the other, right?
Right. But when you flip that onto a sphere, the tops of them should line up.
Which they did.
Right. And the bottoms didn't line up because they're on the curve, correct?
Right.
Right.
Now I understand what you were saying, and yes, the bottoms don't lie. The bottoms will not be, should I say, horizontal with each other because it's continuing over the curve.
No, but the way you presented it, you were trying to argue that the bottoms were lined up, and I was like, nah, they're supposed to be.
No. The only lineup that I was talking about was that the what do you call it? This front one here is lined up with the base of this front tower.
Oh, right. Okay.
Yeah. The back one is lined up with the base of the back tower. That's the lineup I was talking about.
I'm with you. I agree.
But the tops nail it perfectly.
Okay.
With each other. Okay. So, having quite cleanly and clearly showed you that, even with what I am displaying to you, at least matches what the math of the curvature is.
Yeah, I agree. Okay. I agree.
Okay, just so you don't think that I'm pulling any kind of tricks, because you've been driving. I have the model, but you've been driving. Okay. So now I ask you one more time though. This image, or with the exception of the bases and the lengths, as in these little tiers that I got on here.
Yeah.
And as well as the lengths of the actual overall length of these things, there's almost no difference between these two images, except for the fact that the bases here at 3 feet viewing height across a plane, you would be able to see the bases in front of the horizon.
No. Right, that point I agree, but you're saying that there's very little difference between the two views
in overall appearance, because I heard y'all's argument about, there should be some wild, let me go back to the curved one. I'm sorry. Let's see here, camera, curve cam, that there should be some kind of wild arc here. Okay, some kind of even noticeable arc. Okay, of which there wouldn't be over a 2-mile stretch, man.
It's still the size of a house difference between the two views. We should see it.
Yeah, but and you are seeing it. What do you see happening here?
Yeah, but we're not seeing it in the picture.
That's that's now you're getting closer to the point I'm trying to make to you now. Okay. You just watched how this came out on the curve.
Yeah.
And you agree that this is modeled correctly for what would be the curve.
I don't know that I can agree that, to be honest, because modeling this on CAD I cannot do.
Okay, well, I challenge you to throw this at anybody who has any idea about modeling. Okay, I'll just say it that way.
Okay.
Because I just did it, and you can watch my hangout last night where I actually individually modeled each part of this. Okay, so, but what I'm trying to point out to you is that you're saying that there should be a this, or there should be a that.
Yeah.
Okay, where I just showed you in proper modeling
that we can see a difference between the two.
That, with the exception of the base, the image difference is basically identical.
No,
with
it's
the exception of the fact that
Sly, you've got the answer on screen right now. You can see the difference between the top of the one at the back and the top of the one at the front. You can see a difference. So you would see the effect of curvature if there was curve on Ramsey's photo. Why don't you bring Ramsey's photo up that you said was valueless?
Sure, no problem. Right there.
Right. So you can see. All right, I'll give you that the turbines get in the way, the blades, but the hubs you can deduce without you can imagine the turbines not being in the way, the blades, and you can see that there is a straight line between them, and anybody with a crayon could draw it.
Yeah.
But it should be curved.
No, it shouldn't. It's a 2-mile stretch, dude.
No, Sly, you're being dishonest.
I'm not. What? Here, watch. Now, you saw me model this.
Yeah, and look at the difference between the two blocks that you built. You can see the difference without checking it.
Oh, I can show you this. The only difference is that this one slants, the flat Earth one.
No.
A little bit more.
You just move the goalposts. Go back down to the blocks that you made at the bottom to show the difference between the two.
Oh, damn. I'm sorry. Hold on a second. I didn't realize I had both the same camera up. Oh, there we go. That's the two.
Hang on. I'll have to make that bigger. It's too small. Hang on.
Okay. Unchanged. The only difference is that the curve cam one, it goes down a little bit, probably at a slightly sharper angle. But that's it. That's the only difference. That is the only difference between those two images, because on the Ramsey image, there's no discernible what is actually the base or like a landing tier or an engineer's tier or something like that. There's nothing down there.
Sly, answer me this. If we can see the differential between the two blocks that you built and put in at the bottom, why can we not see the differential at the top?
Huh?
On the left-hand picture that we got the blocks visible, put your cursor over the blocks so that I know that you took. Yeah, that block there, the top of that block and the top of that block, we can see the difference. Right. So why is that not translated into the tops?
It is.
No, it isn't, because we don't. I agree with you. We don't seem to see the difference between the two. But why is that the case? Because it shouldn't be the case. If we can see it on the blocks at the bottom, we should damn well see it on the hubs at the top.
No.
Yes.
Let me show you something here. Let me show you something.
Well, unless I'm being a bit dense here and missing something, Sly, it seems to me that you're misrepresenting you're claiming that the hidden height of the two blocks that you made.
Let me tell you what you're missing. Let me tell you what you're missing here. Okay. Let me tell you what you're missing here. Now, obviously, you can see that the doors on the little engineer platform that I built here, okay, the doors are at the horizon level. You can see that, right?
Yeah.
Okay. So obviously, it has sunk down beyond the horizon, correct?
Right. Yeah.
In the curved view. Okay. Now, the only difference that you are going to see between these two images, given the short stretch, and this is 2 miles. Okay, I can measure it out for you on screen. This is a 2-mile stretch between these two, or between the front one and the back one on both sides. They're identical models. They just, one's got a curved floor. That's it. Okay. The only difference that you are going to see is, you see this slant right here?
Yeah.
Okay. This slant is only going to increase by the difference in these two heights. That's all that's going to happen, because you just saw that the tops of these two measuring blocks are now both at the horizon, correct?
All right, I get you. So what you're saying is I'm looking at the height of the blocks rather than the difference between the height of the blocks.
Exactly.
All right. Well, in that case,
because the overall height of the blocks, okay, is obviously sunk behind the horizon on my model here. You saw it modeled out. I can even move the thing around here.
Thinking about this slide, no, I've just had a minute to consider my position, and what you've just said is wrong. It isn't the differential between the two heights that's the issue. It is the block that's the issue. What you've done is we know
why. Ranty, excuse me, Riley. Let me tell you why. Okay, let me tell you why. Because I know where you want to go with this, but unfortunately, you're not comprehending what you're looking at. Okay, what you want is that this basically doesn't exist, and then this right here, it should be a sharp angle, a heavy angle between the base and the bottom, right?
No, that's not what I'm saying. You're saying that the only difference in curve should be the difference between the lower pillar and the taller pillar, which is only 10 pixels. And I'm saying that's not true. The pillars represent the hidden value, so we should be looking at the difference between the two pillars. We can see the difference between the two pillars. I might have this wrong here, Sly, and I don't want to dwell on it, because I'll be honest with you, Sly, it's not my area of expertise, and it's not why I'm here. However,
it's what I will do, you with an area of expertise, honestly, Riley. But
that's all right, and I don't credit the same with you, so we're about even.
Yeah, okay.
Listen, I get your point, and what I'm going to do is I'm going to go.
I just modeled it for you, Riley. I don't know what else I can show you. You want me to go out there in a little dinghy and measure the distance between those silly little turbines out there?
No, Sly, you've modeled it.
Or go ahead and spray paint X's at certain heights on those turbines to show you what I'm talking about.
Come on, Sly, let me respond. I know you've modeled it, but I don't agree with what you've claimed about the model. Is that the only difference in the hub heights that we should see is the difference between the heights of the two blocks that you built. We should be seeing the two blocks, not the difference.
No, I said that's the difference in these two angles, is what I said. Now, do you realize?
So then I don't know which one's right. Are you right, or is my version right? And I don't know. So I would rather give way because I don't want to be wrong on this. On something I don't know what about. So I would rather move on from this and say, Sly, if you're right, you're right. But I know somebody that can tell you whether you're right or not. So what I'll do is I'll go away and I'll tell him what you've told me, and I understand your point. It's the differential between the hidden heights that you've got on screen, not the hidden heights themselves. It's the differential between the two. And I don't agree with you.
That's what develops this angle over the short period of 2 miles.
Yeah, but it's an exponential curve. That's why it's not the differential. It's from
Riley, exponential or not, it's 2 miles.
Doesn't matter. It's 2 miles from 11 and 2 miles from 13.
Right. It's 2 miles.
Right, but it's still 35 feet. I get it.
No, you don't get it.
Riley. No, I do. It's stalemate. I don't know if you're right, and you're saying I'm wrong, and I'm saying I want a chance to go away, and I want to find out whether you're right or not. And if you're right, I'll tell you. If it turns out that you're right, I'll tell you.
Let me tell you the point that you need to go discover. Okay? Because obviously you're going to go off on a mission of discovery, and that's fine. Okay? I accept the fact that you are saying that you do not know enough about this to be able to hammer it down. I got that. I'm cool with that. Okay? But let me tell you the mission of discovery that you have here. Okay? From the first one to the last one is 2 miles. Okay. Now, what I'm going to ask you to find out along your mission of discovery is how much of an arc of the curvature, how much of an arc, don't get yourself caught up in words like exponential and all this other stuff. How much of an actual arc are you to get out of the stated circumference of the Earth? Okay, because you're arguing against the globe model, so you have to use their numbers.
I get your point. I understand your position.
How much curvature are you expecting to see out of 2 miles?
35 feet is the answer.
No, that's an end number. You're talking about a missing arc. There's no arc to be seen.
Yeah, that's the point, because we don't live on a ball.
No.
It should be there, Sly. It's 35 feet differential between the first and the last one. You can't get away with your ball maths.
And I just modeled it for you. And do you see a wild arc here?
Yeah, but that's the point. There should be an arc here. Sly, your two pillars that you put in at the bottom, them pink things at the bottom on the left-hand side,
right?
They show that we should see some curve drop.
Yeah, and you do. I just showed it to you.
Yeah, but it should be manifesting the tops, not just the bottoms.
Right. By this wee little bit.
Yeah, and I get you.
A little bit here.
And like I said, I've got your point.
You see, I got it at the top right now, right?
Yeah, we see a differential, right?
It's only going to increase by that much.
Yeah, but I'm saying that's not the correct ruler. What you should be doing is the whole height. You've got the whole height at the front, and you've got the whole height at the back, and you should see the differential between the two. You should.
Okay, so?
So I'll go away and find out whether it's modeled correctly or not, because I've said to you, I think you've done something different. Or at the end of the day, Sly, my position is we should see it in the hub heights if it's there in the base.
You do see it in the hub heights, but you're looking for an arc that's not there.
So you say. I don't believe you, and I don't trust you. Here, so I'll go away, and I'll find out if you're right.
No, hold on. Let me do one last thing for you before you go away, as you said. Okay, I'm going to put this camera back to where it was when I first opened this back up. Okay, because I want you to take a look at something. Okay? So I'm going to go back up here to the top.
Brazil have been knocked out by Belgium, by the way.
I don't really care that much.
Okay.
Okay, so this is on the curve one. Okay, this is the above the curve set. Now, what I'm going to do is I'm going to move the camera's target to the center of the curve, or excuse me, to the center pillar. There's 9 of them. I'll put it on the 5th one. Okay.
Sly, I understand.
No, you don't understand what I'm going to do because I haven't done it yet. Okay. Now, what I'm going to do is I'm going to look at the side view because you guys love that side view.
You're not going to see it on side view. Sly, you would need to move your camera all the way back to get 11 miles in your field of view.
I did. You dumbass. I have it modeled at that length.
So where's the first and the last turbine?
At 11 miles, then to 13 miles.
Okay.
Jeez, did you not look at anything that I just did?
Yeah, but I thought you were doing
Yeah,
it.
but what?
I thought you were doing it based on the turbines being at 11 and 13 miles, not
11 and 13 miles. That's what I modeled because that was your statement.
Yeah, but when you've gone to orthographic view, are you moving it back to allow for that 13 miles of curve?
When did I go to orthographic view?
Just in the last 10 seconds.
Oh, right now, because I'm just moving a camera. I'm not looking through the camera.
It's like,
you moron. Look.
We're getting to the point where we're wasting time here, and I want to get onto the main.
Yeah, you're wasting somebody's time. Now watch. Now let me zoom back out. Okay, so here's what I got.
So are you showing me 2 miles there, or showing me 13 miles?
You want it from 13 miles?
Of course.
Sure, I'll put it at 13 miles. Who gives a shit?
Well, then we're gonna
some way to deny it anyway.
Well, then we're gonna need a straight line from the height of the
How much is 13 miles in kilometers?
13 miles in kilometers.
Yeah, math sucks. I know.
13 miles in kilometers is 20.92.
20.92. Okay. Do you agree that I just typed 20.92 into this tape measure?
Sure. Now we need a straight line of reference.
Hold on. Okay. So where did that go? I just did that. Oh, I put. Yeah, that was funny. 920. It's in meters. No. One more. Come on. You saw what I did. There we go. All right, so let's move this camera out. Is that how far away the side view is supposed to be?
If you're going to be viewing 13 miles from one angle behind it, you need 13 miles orthographically as well, yeah.
No, actually.
This is the point. This is the point. It's not 2 miles.
Point is that you're just making shit up now.
No, you're just not modeling it correctly.
What?
You need a straight line going from the beginning so that we can see the curve drop.
Did that.
Where's the straight line from the beginning?
No, this is looking at the side now. We've moved on to what you didn't understand before.
Yeah, but we haven't got a frame of reference. We need the straight line.
What frame of reference do you need?
So you need to put a straight line from the the 13-mile bit at the beginning, which is far to the left.
To where?
Basically, right across the top, so we can see the tangent line.
Oh, you mean from here? Is that what you're talking about?
No, from 13 miles away, left.
I'm at 13 miles, you moron.
Really? That's 13 miles?
Yeah, zoomed in at 13 degrees.
No,
should I zoom in some more?
No. You need to see left.
Go ahead and zoom in some more. How about that? Is that good? Can you see it now?
No, you're not modeling it correctly, Sly. Come on.
I am modeling it correctly. You're just coming up with shit.
All right, listen to me carefully. The furthest right turbine, that needs to be 15 miles away from summit on the left-hand side, 15 miles to the left. Because that's where you get your build-up of your exponential curve.
What the hell are you talking about?
You've just been viewing the turbines from 15 miles away, correct? From behind. We need to see that
from behind. What are you talking about?
Oh God, Sly, can we move on? Because you're not getting.
No, you're just coming up with shit. Speak,
no,
man, speak. English is a fucking language. Use it.
Yeah, you were modeling it from 15 miles from behind, were you not?
What behind? Behind what?
The turbines.
I haven't put anything behind anything. What the hell are you talking about?
When we had the flat and we had the curved cam and the flat cam,
right?
You put them blocks in, them 2 blocks,
right?
And my point is, we should see the difference between the 2. Correct?
You do.
Right. Hang on. Wait. That was modelled from 11 and 13 miles away, wasn't it?
Right.
Right. So I want to see that 11 and 13 miles laterally now.
That's what I'm doing.
No, it looks like you're doing 2 miles.
No, I zoomed in.
So that first turbine there, put your mouse over it.
Did I not just ask you what is the distance did I not just ask you to convert your miles to kilometers for me, right?
Sly.
And what I did, and shut up.
I'm not asking.
What I did was I put a tape measure from the turbines, handed out here, and then put a camera out at the end of it.
Yeah, but what I want to see, Sly, is that there's 13 miles from that last turbine to an arbitrary point 13 miles to the left. That's what I want to see. And then I want to see a tangent line. So we've got
13 miles. What, you mean you want 13 miles of the stretch?
I want to see that last turbine on the right being the 13th mile. I want to see the first
You just
turbine.
had that. That was when I was at the front of the damn thing.
Yeah, but now you're doing it side on, are you not?
Yeah, and now I'm what? How many kilometers or how many miles did you just tell me to put this thing at?
Enough so that we can see that same 13 miles from that camera. In other words, you're reducing your field of view so that we see that whole 13 miles. Then we have a tangent line.
Oh, you want to see 13 miles from what the original observer point was to the last one from the side.
Correct.
That's what you want.
Yes.
Okay. Do you have a 13-mile stretch of turbines that I'm going to be comparing this to?
Well, we're going to put a tangent line in.
Do you have a 13-mile stretch of turbines viewed from the side that I can compare this to?
You're going to show me the orthographic.
Do you have a 13-mile stretch of turbines?
So then you can't go to the side profile view at all.
Of course I can.
No, you can't, because nobody ever takes a picture of the side of their own head. You either do what I say, Sly, or you
absolutely nothing about what you just said made sense.
Because you're either deliberately playing dumb or you don't get it.
What I'm showing you is you guys love to put this little side view up of these things with you got a red line and a blue line. No, shut up. It's my turn. Okay. Now, you guys love to put that thing up and you're expecting to see some wild arc and all this. I'm showing you the exact same model that I just showed you, which is an accurate scale. Shut up. Is an accurate scale representation of exactly what those turbines should be across that stretch of surface. That
but you haven't done it.
2-mile stretch of surface.
Yeah, you haven't done it, Sly. You haven't done
doing it right here.
You haven't done the same representation. You've only done it over 2 miles. You need to do it over 13. If you don't do that,
and then now I ask you the question again. Then, do you have a photograph of a 13-mile long stretch of turbines from the side?
No, we have a photo.
And why are you asking me? Why are you saying I'm modeling it wrong?
Because we have a photo of a 13. Sly, listen. We have a photo of a 13-mile observation, and you're showing a side profile of 2. You're dodging the point.
You have a 13-mile away observation of 2-mile stretch of turbines.
Yeah, but from the lens camera. It's not from
Who cares? Do you have anything in the beginning here? Hey, no.
Yeah, that's
Riley.
That's the dodge, Sly.
No, what it is? What? It's a dodge?
It's a dodge.
How's that a dodge? Tell me how it's a dodge.
From the lens of the camera, Sly, that's the beginning. That's the 0 point.
Right. Okay. So what do you have between the camera and that 11th mile, at least, to judge this on?
You're going to put me a tangent line.
What so we can do you have to judge this on?
A line of sight.
11 miles.
A line of sight, Sly.
Line of sight has nothing to do with anything in that.
It absolutely does, Sly. We have a line of sight up to the top of the hub, and we have a line of sight to the bottom of the hub, and you're not showing it. You're showing 2 miles orthographically.
Want me to draw lines for you? Shit, I can draw lines all fucking day.
So get over to 11. Go to 11 miles to the left of the picture and draw a tangent line to the top.
Perhaps if you weren't such a moron and actually told me that you were looking for tangent lines, I would have fucking drawn them.
I did tell you tangent lines.
No, you didn't. You said put your camera out there at 13 miles away.
No, I didn't. Listen carefully.
Hold on a second.
That's not what I said. I said tangent line. I said a tangent line from 13 miles away.
Shut up, Riley. Hold on. Fucking moron.
Well,
okay, so
we have language for a reason.
Tangent lines. Shut up. You want tangent lines?
Yeah, from the same height as the hub.
From that what?
So basically, grab one of them turbines and copy it and stick it there, or stick it from the camera height, because the camera height would have been what, 3 feet. So draw a tangent line.
I got the camera height right here. It's still marked up.
So draw one line into the top of the hub.
Okay, hold on a second.
And this is from 13 miles away.
Which hub specifically?
The first one.
First one. Okay. Shit, now my camera's in the way. Move that back over there. Okay, so this is the line that we're drawing up to. I'm going to put it at the base of the hub. Fair?
Sure.
Okay, base of the hub. That way we have an agreed upon meeting point.
But you're going to have to continue that line beyond that point, because that's the line of sight that we see is straight.
Okay.
So carry that line on that bearing or that angle, whatever reference you're using. Continue that line in a straight line.
Oh, fuck. Okay, hold on. Now this is actually gonna be kind of fun to do. just because of the fact that that's not the way this is set up to go, but that's all right. I'll make it happen. Now, I'm going to just extend this out to oblivion.
Sure.
Well beyond everything else. Now, what I have to do is just to make sure, for the purpose of accuracy, I know you don't care about that, but for the purpose of accuracy, I need to make shut up. For the purpose of accuracy, I'm going to make sure that that line remains in the same place. See how it went up a little bit?
Sure.
So, you know, because I actually do care about accuracy. And let's see here. So let me go ahead, and now that line is extended out perfectly.
Excellent. Now we can go along to your orthographic view, and let's see how much they
We're in
deviate
the
from that line.
orthographic view right now. So what do you want to see?
Well, so this is on. Are we on curve cam or are we on flat cam?
We're on curved surface in orthographic view. We have nothing to do with the cam right now. The side view
Curved surface, right? So we've got the straight line that goes straight through the first hub, which will be the line of sight on the photograph going through the first hub. So let's go back to the photograph and look at the photograph.
Okay. Oh shit! I fucking closed it. Not bad. Okay. So what are we looking at?
So what we need to do to make this match the photograph is somehow make that line go down when you've just been drawing it up.
Huh?
Yeah.
No, I didn't understand what you said.
So you've just drawn the line through the center. You've got a straight line going straight through the center of the hub from the lens of the camera. Agreed?
Base of the hub on the first turbine. Yes.
Right. So if we had a straight line of sight going to the base of the hub, we've got the line going straight through the bottom of. Go on to the photo.
Yeah.
Move the photo up. So our straight line of sight should be going straight through the bottom of the first hub, and then in a continuously straight line, the line would continue off in the background, wouldn't it?
It continues to miss the rest of them. Yeah.
That's right. So that's what the photo would do, right?
That's what you're seeing in the photo.
Right. But because we've now
got.
Yeah, but hang on. No, hang on. Let me make this bigger. Let me word this carefully so I get this right.
Oh,
so the straight line you've just drawn right the way through there. What we then need to do is, hang on, let me work this out. Can you zoom out your graph thing further back so I can see? Is that all of them? It is, isn't it?
That's all of them. That's all 9 of them.
Right. Let me think about.
Even though the photograph only has 7.
Okay, just give me a sec. Let me look at this and work out how this needs to be.
Because your FE course guy is, interested in accuracy.
So what we need to do is we need to show that because we've got a straight line on the turbines on the photograph, you need to show that there's a straight line from the first turbine to the last turbine in a straight line on orthographic view. So basically, we've got the tangent line in. So draw a line from the first turbine to the last turbine and show that it's straight. Because if it's not straight, then you're not matching the picture. Therefore, you disprove the globe. Agreed?
I have no fucking clue what you're talking about.
Draw a straight line from the base of the first turbine.
I have a straight line here. The green one. That's the line you just told me to draw.
Yeah, hang on. All right. So if that's straight, hang on. Let me think about this.
As a matter of fact, here, let me go ahead and turn the grid off so it's easier to see. There.
Yeah, that's a lot better. Right. So can you move that up towards the top of the picture, or pan your thing down a little bit so it takes up less space because I want the picture to come back up. Yeah, that's it. And then bring up that picture again.
Okay. Go ahead.
So
I'm hoping at some point you make a point here.
Yeah, I am making a point. I'm just trying to translate what you've done orthographically into a perspective.
Okay, what you're looking at right here is this line right here goes all the way back to the point of observation that we had at 1 meter above the water, right?
Yeah.
And then what we did, this is a line of sight. Okay, this is a line of sight from that position to focusing on the base of the first hub.
Yeah, I get it. Right, I know what we
need the first hub. Now, hold on. And what it's going to do is that line of sight is going to continue, and you see these things falling lower and lower and lower below that line of sight. So if this photograph was taken from 1 meter above the water,
yeah,
looking at the base of this at the base of this hub,
Yeah.
Okay, then you are going to see the ones that are beyond it lower than that point.
Right, I agree. Now, Sly, I know what we need to do here.
What do you need to do?
It was the point that we were doing before. Now we've got the straight line of sight as a reference. I want you to draw a straight line that goes from the base of that first hub, and then pass through the base of all the other hubs in a straight line.
Oh, you're looking for that bend that's not there. Yeah. Okay.
Yeah. So draw the line straight to the first one.
No. We did this one last night. This one was kind of funny. So I'm going to in the position of accuracy.
Yep.
Okay. Now that's where it is right there. Now I'm just putting that off to the side so I can grab it easier. And then we're going to move this over to here. And then I'm going to put it right here at the base of this one.
No, the last one.
That is the last one, isn't it?
Okay.
Yeah, that's the last one.
And now pan to your left and show that they all go through the same point.
Sure, no problem. Okay, so actually let me get this other line of sight one out of the way.
No, keep it there.
Oh, okay? I don't know what use it has right now.
It's a line of reference. It's the line of sight.
Yeah. Okay.
Just keep it there.
Anyway, here we go. Now, mind you, we're concentrating on the lower line.
Hang on. Sorry, go back left there. Did it go through the bottom of that thing?
Yep, right here.
Yeah, okay, go on. Let's see the next one.
Wow, look at all that horrible curvature. Wow.
All right.
I bet there's a huge arc you're waiting for here. Oh, maybe it's on this one. No. How about the next one? Think it's on the next one? Big, huge arc? Nope. Not on that one. Okay, what about the next one? Come on. Bets? Anybody? Bets?
No. All right.
Okay,
I'll give you that one.
Now let's
I'll give you that.
We need to look at all of them, you see. And then all the way out to the end. Okay. No big arc. You know why I'm making fun of you about that? Because I tried nicely before to explain to you that 2 mile stretch is not going to give you a wild bend. Period.
All right. Right, Sly, we're going to move on because I don't want this to be the main event.
Yeah, because you don't like to sit on things that actually...
No, because it's not my area of expertise, and it's not fair to dwell on this point when it isn't something that I'm here for.
It doesn't need to be your area of expertise to know that a line did not create a huge arc.
All right, fair point.
You need to have a level of expertise to know that this line did not produce a great deviation among these 9 items over 2 miles.
All right, and I've said I'll give it to you at this point, but I'm going to go away, I'm going to look into it and find out what's not right.
And I want you to make sure that tomorrow when you guys have whatever discussion you have and Riley and Nathan brings up his stupid picture of the side view of the turbines with all his lines on it, you could show him that if it's only a stretch of 2 miles, you're not going to see a bend.
All right. Well, like I
I'll
say,
be looking forward to those words coming out of your mouth. Anyway, next thing that you want to get wrong.
And I will come back to you with an answer either way. And I'll say, if you're right, I'll say, Sly, you know what? You were right. If you're wrong, I'll say, Sly, you lied. You got it wrong. You did whatever.
I'm sure you'll say that too.
Yeah, I will. Right.
You won't back it, but you'll say it.
No. All right.
Anyway, next.
Let me open it up. So, what we're going to do here, Sly.
It's about time for me to take my dog out.
Yeah, it's all right. I'm having some food as well, so we're good.
No, you don't look like you need it.
Do you believe it or not? I've not eaten all day. Have we? Have we had anything to eat?
Anyway.
I don't think we've eaten all day.
Last point. You got 10 minutes, man.
I don't think so.
What do you mean you don't think so?
If I've got 10 minutes, Sly, I'm going. There's no point even starting. This is going to take a while because you're not going to agree on this at some point, right?
Well, go ahead and tell me what it is.
Right, I'm going to have to do it. It's not doing a slideshow on this monitor for some reason. Let's try. It might be because it's the wrong size. Hang on. Right. Nah, it's not frigging working.
Am I going to need this model anymore?
No, you can get rid of that.
Sure, you're glad to see it go.
All right, so I need to share my screen, don't I?
Oh, you want to share your screen?
Yeah, of course. How am I going to present to your subs the current position, right?
No, what? Well, no, your position hasn't been too current lately.
Hang on, hang on. I need to make sure that I don't present to everybody just yet. Let me get my screen shared and then get this thing open. Right, now you can share your screen.
You mean your screen? Hold on a second.
You see my screen, yeah?
Presenting to everyone. There you go. Oh, great. Here we go. Going all QED on us now?
Well, no. This is all pictures, pretty pictures. No text-heavy documents. Love you, John.
I would argue that pretty is not the word I would come up with, but go ahead.
Come on, we're looking at perfection personified there, man.
Yeah, okay, whatever.
Anyway, right. So for the benefit of your subs, you made some representations recently that I disagree with. You claimed that I've got curvature evidence in my own footage, and we're going to address that right now.
All right, you got to move on.
The way we're going to do this, we're going to start with things that we agree on. And we're going to, there's only 20 slides, 30 slides, and we should agree on almost all of them. And the further down that we get, it narrows the points of disagreements. And I'll be honest, I'm not expecting you to disagree with me until at least the 20th slide. This is mainly
the 20th slide.
No, because I'm telling your fans, your subs that have heard you spouting my name in a bad light, and it's only fair that I get the response because of the shit you're talking. So I'm going to go through them, and most of them are really quick. And we're going to start with the simple question that you can't answer, and it is, why can we see this land? And we're going to come back to it time and time again, okay?
Mm-hmm.
So we have a historical background argument, don't we, between me and you, which is I made a
nostalgic, man. Just give me just move on.
I made a video 8 months ago, and I asked what was the land that we've seen in this video, and it's called Ireland from England. Explain this with evidence. And the question was, what is this land? Now, I thought it might be Ireland, Scotland, or Isle of Man because it shouldn't be seen on a globe Earth, and that was
tax and all that other stuff. Actually, that part was quite plainly seen. You just got your heights wrong.
Sure, the heights were part of the issue, but even with the heights the way they were, we still shouldn't see this on a ball. Even at 110 feet, this is still gone. The only bits that you guys brought back were the tippy tops of it, but we don't see the tippy tops of it. We see a lot more than tippy tops. But because you guys are dishonest, you guys think that bringing back the tippy tops of it is enough to justify what we see in the picture, and that's nonsense. So I have the issue. The issue was, what was the land? So we worked out that the land was the Isle of Man. And at the time,
worked out that the land was the Isle of Man. You denied it for about a month, actually about 2 months.
Sure. Now, at the time, you said to me, "Go back and get it from the beach." Do you remember? You don't deny that. No, you do remember saying that, right?
Oh, of course, I did. So
I'm still working on the why can we see this land question, right? So at the distance that we were at the time, at 100 feet in elevation. Basically, the 246 refracted hidden wasn't enough to bring it back. 350 without refraction wasn't enough to bring it back. But you guys claim victory. But it's cheating, really. But anyway, I went back 2 months ago and I got on my belly on the beach, and I got the same land. So you can see this on my channel. It's called Flat Earth, the original video 2 months ago. And at 2:05, we see land in the picture. To be fair, you might not be getting this in the resolution that it is on screen. But it is in the video and it can be seen. And in the video, we can see that this land is presented at 1 minute and 19 seconds. And you basically turned a Nelson's eye. You said that you definitely couldn't see any land here. What land is there here? You were playing funny buggers. And that's why I forced you to admit that you could see it, and you wouldn't do it for ages. So basically, your position at the time was, well, even if that is land, where's Ramsey, Riley? Do you remember that?
Well, that was one of the questions I asked you, yes.
Sure. So back to the question, why can we see this land? At this point, you weren't prepared to accept that the land was even seen. And largely it was because of the weather. And I'll agree, the weather wasn't perfect. The weather was a little bit shitty at the time. It wasn't ideal. But I thought when you said, where's Ramsey? I thought, right, well, I'll go back and get it. But even at the beach, 10 feet of observer height, you said 5. I put in 10. 34 miles gives us big numbers there that the land isn't big enough to be able to be seen. However, it gets worse. When you asked for where's Ramsey, I thought, right then, okay, I'll try and I don't think I'll get Ramsey. Waves are a thing, perspective.
You still haven't gotten Ramsey.
Things in the foreground obstruct things in the background. So I went back and I got an observation just a couple of days ago whilst England were playing. when they were all doing penalties, when it went to penalties and extra time, I thought I'll just nip out now, see what the weather's like, see what the visibility's like, and if it's good, I'll grab my camera. It just happened to be good. Grab my camera, and then I came back and made this video. If Ramsey, Earth, flat. Now, in this video, at 8 minutes and 10 seconds, we can see that there is some... Can you see my cursor?
Oh, yeah.
We can see that there's some land on the side, which you've admitted and accepted that is land. Thank you. Took a while, but, you know, we've got there in the end. But we also see that there's some land here. Do you agree that there's some land on display here?
There's something there. I wouldn't even consider it land.
Okay.
You called it Ramsey, but, you know, hey.
Well, yeah, you asked for Ramsey, right? So I was referencing what you asked for rather than specifically the exact town.
But even given the position that you say that is, Ramsey's not even on that portion of the island, dude.
Sure, that's fine. But at this point, we're still going with the question, why can we still see this land? So don't lose sight of the question. I am coming to it anyway. So we're getting up to 16 and we're still agreeing. We're all good at this point.
Mm-hmm.
So the distance is like 32 miles from where I'm looking at, but that's to the coast. The land that we're actually looking at goes beyond the coast on a funny angle. And it's basically, there's 4 miles over this stretch. So anywhere along here is, I've gone for 2 miles in the middle to represent the highest point of the land that we see. So I've put it at 34. Are you all right with 34?
Do you want to call it that?
Sure. So I've used 34 because it's the halfway point. Put my observer feet in at 10 feet. I know you said 5, but I'm all right with 10 because it doesn't make any difference. Gives us all these values in yellow. And I'll be coming back to these values in yellow. We don't have to remember them at the minute, but I'm going to be focusing on these because these values basically prove that we cannot live on a sphere the size they tell us. Okay? So I'm not going to dwell on these at the minute. I'll come back to them. This slide's repeated in a bit. So we have, in the video, we have this land that's on show, but we also have a little bit of land off to the left. And
it's called Ramsey.
Yeah, which I did call Ramsey. And it was to distinguish it from the hills at Bride. And I know that you get that. And I did say I'm not going to dwell on whether it's Ramsey or not. I'm just distinguishing it from the hills at Bride. But we see there happens to be a little outcrop of land to the left of the hills at Bride. And in the video, we see what I'm going to say is these are the hills at Bride. And there appears to be a small patch of land to the left of it, just like we see in the Google Earth. So I'm going to claim that that land probably is that. Might not be, but I'm going to claim it's that because it matches. It seems to match. So we're going to go back to this question to remind your audience what the question is. Why can we see that land? Now, this is where it gets a little bit trippy. So this is where we're probably going to start disagreeing, and feel free. This is where we go back to the numbers, because at 34 miles with an observer height between 5 and 10 feet, the value, do we agree that the value from the beach is basically the drop?
The drop?
Sure.
What are you using drop for?
Well, you tell me. What should I be using?
You should be using hidden if you're talking about obstruction of view.
Really?
Yes.
So do we need...
Why would you use drop?
Let's bring up the curve calculator. And
why would you use drop?
Well, because we're on the beach, right? And if we look at Magic website, let me get my cursor back. There we go. We see, let's pull this over here a little bit. I need to zoom out of it. So when the observer height, which is this one here, basically is on the beach.
Right.
The drop is the line of sight, which we see, eye level, line of sight.
From eye level, yeah.
Yeah, eye level.
But you realize that across a spherical Earth, eye level does not change as far as viewing something across the surface.
Yeah, that's right.
You're using drop, and that's incorrect. And I corrected you on that a couple of times before, which you have ignored.
But I seem to remember you saying that the only time drop would be used is if you're on the beach. Is that not right?
No. I've never said that, because I've never said that drop, when it comes to what we can see and what we can't see, drop is not really even something that's brought up or used.
So, all right. So that isn't telling me why we shouldn't use drop.
Because drop does not judge your what you can see or what you can't see. Hold on a second. Very simply put, Hold on.
For those of you wondering what I might be eating, I'm eating the KFC because I'm starving.
Yeah.
You'll have to bear with me while I eat some food.
Okay, hold on a second here.
I'm withering away.
All right, so sorry, not very to scale, but you'll understand in a second. Okay, if this is a spherical Earth, okay, or a sphere that you're standing on, or a fucking hill, who cares? Now, if the bottom of this line is your line of sight, level to where you are standing, okay, drop, in this case, is what falls down, okay,
Yeah.
is what goes down. That is not. That has nothing to do with nothing directly to do with what you see, okay?
Correct.
Because you are not at this point. You're not looking out up this way to judge how far it fell down. You are looking at the object, whatever the object is, right? So what you are looking at, oops, what you're looking at is actually. I gotta make this change this color here. This right here is what's in it is blocking your view of whatever object you have over here. Has nothing to do with this. Do you understand that?
Yeah, I understand. I'm just trying to get you to tell me because I've never been on a position where I'm at the beach before, getting an observation.
Yeah, but the beach or in a skyscraper has nothing to do with it. Okay, beach or in a skyscraper. This is a tangent, man. Okay, or actually, I think the proper word is a chord. Nevertheless, this is the so-called bulge that everybody thinks is some wave of water that's out there and all this other stuff. No, no, no. Okay, the thing is that you keep using drop as if that means something in a visual sense.
Yeah, and
which it does not.
You keep saying that I'm pointing my camera down, and I don't think I am.
Okay, well that doesn't excuse the fact that you're doing the math wrong.
Well, you tell me what the math should be, Sly. You're the ball and making the assertion that we live in a ball. You tell me where I'm going wrong.
I just did. Using drop is incorrect when you are trying to judge an observation.
So what should we be using then, Sly?
The hidden height is what's in front of what's blocking your view.
All right, so let's go back to the hidden height then. So do you want to drop your screen so that I can go back to mine?
Oh, I already know where you're going with this, but yeah, that's all right. Hold on a second. Okay, like I said, we're now over the 10 minutes, so now you got like 3 minutes here.
Then I'm leaving. We're nearly there, Sly. This is going to be concluded whether we got 10 minutes or not.
How long does it take for you to make a fucking point?
Not that long.
Well, then make your point.
So we're going to go with the hidden height.
Right. You don't go with drop.
All right. So we're going to go with the hidden height, 605, and that's without refraction. We'll include the refraction, 508. Do we know how high the land in question that I'm identifying is?
It's about, what, 250, something like that?
So remember the hidden height. So we've got the hidden height of 508 feet, and it's about 250, right?
Yep.
So basically, let's move that back up there. 250 feet represents this mound here, and we have this one, the one next to it, that's about 100. You can check it check it on Google Earth if you want.
No, I know the height.
This gives us a scale. So we've got 100 to 250 there. But we should have a wall of water. Well, we should have a hidden height of 508.
Okay, the first thing that you have to do before you make a scale is realize, or at least concede, that there is absolutely no disturbance in the direct line of sight of the image. You do not have that assurance here.
Minor point, and I don't think it's relevant.
No, it is a serious point.
Hang on.
You see what I've been playing on my screen for the last, I don't know, 10, 15 minutes?
Hang on, there's another problem before you go to DANG JOS.
Do you see what I'm have on my screen and have been playing for about
before you go to DANG JOS, there's a problem.
Do you see what I am playing on my screen?
Are you talking about DANG JOS?
Yes.
I can see that. I'm well aware of that argument.
Okay. Now, would you agree that the stuff that is actually being pulled up over there is not the exact size of the red putty that he had on the other side of the canister there?
But do you agree that you're using a sledgehammer to knock in a panel pin?
No, I'm using common sense with you, dumbass. Okay? You
That's
want to
fun.
say you want to turn around, you want to tell me that you can actually get some kind of a solid measurement out of distorted viewing. You want a solid measurement out of that. Is that what you're telling me?
I'm telling you that you're even jumping the gun. I haven't
No,
finished making my
I'm
point.
asking you a question. You should answer it. Is that, are you telling me that this kind of disturbed crap that you have on your screen right now
Yeah.
is something that you would consider accurate enough to get a measurement from?
So, yeah, I am saying that, yeah.
You are saying that? Good night, Riley. Because that's the stupidest thing I ever heard.
Really?
Yeah, it is. Really.
All right.
Tell you what you do. You go on Nathan's tomorrow, you compare this footage to the raised up footage, and you show me that it matches identically, vertically and horizontally, then I'll invite you back. Cool?
So you're an evidence denier then, Sly. You won't accept the
No, well,
evidence.
I'm telling you that the shit that you're showing me right now is absolute crap to use as a measurement.
No, it's called an estimate, not a measurement.
No, you're
estimate.
using it as a measurement.
Yeah, I'm using it as an estimate.
Riley, go ahead and make that comparison. I'll invite you back. I gotta go.
Laters, runner.
Excuse me?
You're running, Sly.
Yeah. Okay. Well, run to that purple dildo. I hear her laughing. Later.
Bye.
Yeah. I'd rather be called a loser than actually be one. So.
All right,
anyway.
you'll be an awful lot more things tomorrow, Sly. You're a runner. You're an evidence denier.
Oh, I'm sorry. Am I a runner? Ask your girl to get the measurement height of those 2 points that you just had there.
It's all right, okay. Sly. The conversation's over.
Did you
You're a runner, Sly. Come on a minute. You're a runner.
No, you're just this dumbass, dude. Good night.
Have fun.
So, ladies and gents, tried to get him to compress it. This is the Dang Jos video. Oops, excuse me. This is the Dang Jos video. And I just wanted to point out that as cool as this is, I would not use this bit that's going up and down here as a measurement for anything other than the ability to optically see it. He's saying that it is something that you can base a measurement off of. Until he can show me that, I have nothing else for him. Ladies and gents, it's time for me to take out my dog. I hope y'all have a great night, and to all the little Nathan Oakley fans and stuff like that. By the way, he did want to present his stuff correctly. That's pretty much it for me now. Y'all have a nice night.